Okay, so this is tutorial on assignment 7, which is based on case 8, which makes things a bit confusing, right? Cases have like n plus 1. Well, I don't know how you feel about it. I find this case and this assignment to be quite interesting because it involves using Microsoft Excel Solver. Again, I don't know what you experience with Excel and Microsoft Solver, but I've met a lot of people who just love Microsoft Excel Solver so much. I mean, they love this functionality because it's very useful in their daily tasks. I had a student, when I was in Abu Dhabi University, we had a graduate student. He just fell in love, and he was like a preacher, just like, approaching everybody and offering his help with Microsoft Excel Solver and, just praising it, how useful it is in various scenarios. And, he worked for Abu Dhabi ports. And it was very useful in his job for allocating resources, for dispatching people, like cranes and all those things. So he was like a very strong proponent of this feature. And indeed, it looks interesting because it's an element of artificial intelligence. With Microsoft Excel Solver, you're asking computer to act like a human in some cases, to act like a human for solving a problem, including nonlinear problems. Problems that only humans are good at, because humans are capable of this nonlinear kind of random thinking that sometimes is flawed, but also sometimes is very useful because it allows you to tackle problems that don't have like a strict mathematical solution. So as it turns out, Microsoft Excel can do something like that as well. So that's why I find this assignment to be very interesting and very useful as well. So let's start with the case. This assignment is about a company called Saint Bernard Bus Lines. How would you pronounce Bernard? Without D? Or Bernard with a D? Okay, so I'll say Saint Bernard. Okay, so this is a bus company, like similar to Greyhound. Have you ever tried Greyhound? Or, no? Yes. I have this dream of crossing the United States on Greyhound buses, but I haven't allocated time yet. Well, anyways, it's similar to Greyhound. This company is similar to Greyhound, although it looks like it's much smaller. Okay. Now, look. This is very important to understand. First of all, those constants, something that is given to you, because we'll be using those constants throughout the case. Look, they have several bus types. Okay, how many in total? You see, they have 4 models of buses. Okay, now each model is different because each model has a different passenger capacity, ranging from 49 to 59. Okay. Also different cargo capacity, you know what I'm talking about, right? In addition to carrying passengers, they can also carry cargo space. They have cargo space for carrying cargo. And they also have operating cost per mile. Some models are cheap, relatively cheap. They cost, let's say, $3.50 to operate per mile. Other models are relatively expensive. Like this model that has only 49 passengers costs $5.25 per mile. Okay? Now, also we have operating cost per mile. In addition to operating cost per mile, we have operating cost per passenger per mile. So basically, it says like this is how much it costs you to transport one passenger for 1 mile. I don't think we're going to be using this parameter anywhere. Okay, but this amount can be calculated by doing what? Yeah, dividing E6, which is operating cost per mile, by the passenger capacity, right? So that's how you get this amount. Now, this is also very important because it is used in constraints section. We're going to talk about it later on. But just remember, this company has certain quantities of those buses, and also you cannot exceed those. You cannot allocate more than those quantities that are available. Okay. So for this specific model, CT hybrid commuter coach, they have 12 buses available. Okay. So this is the constants section. This is the setup. Any question? Does it all make sense so far? Like about this company? And once again, they're transporting people like Greyhound. If you want to ride, let's say from Paducah, to Philadelphia, they will sell you a ticket for that, and you'll ride one of their buses, something like that. Okay. Now, speaking about Philadelphia, one thing that is important to understand is that they're using the so-called hub and spoke framework for managing their business or arrangement. Basically, what it means is that their headquarters are in Philadelphia, and all buses, they basically travel from Philadelphia to all those cities. Okay? So if you want to go from city to city, it has like a star topology, right? So you need to go through Philadelphia to travel sometimes from one city to another city. Okay? So that's how it works. Now here, you have fees. first of all, you have ticket prices for each destination from Philadelphia. So for example, if you want to buy a ticket from Philadelphia to Baltimore, you'll pay $90. Okay, and here you have ongoing cargo price per pound. So in other words, if somebody, if you're carrying 1 pound from Philadelphia to Baltimore, somebody, whoever owns that cargo, will pay you 21 cents. Okay, so that's those are the fees, those are the revenue items that you'll be getting. Okay. Here, so those are the concepts. Now here you have a daily report from a manager. Okay, so before the day begins, let's say at night of the previous day, managers report to you how much demand they have for each of the destinations. So basically, what well, first of all, here you have distance from Philadelphia to each of those cities. Okay, now here you have daily passenger booking. So imagine each location has a manager that sends you demand information before each day. Okay. So they told you, well, we already have 500 people who book tickets from Philadelphia to Baltimore. Okay, so the demand is 500 tickets. And the same thing for daily shipment demand. So this is how much you got you got in shipments from Philadelphia to Baltimore for this specific day. By the way, if you open Skeleton for this assignment, I think I made a mistake. I don't know why, but the daily cargo shipment is wrong in my Skeleton. So make sure you have those numbers. I think I made like some mistakes in the last 3 numbers. Okay, and I don't remember what.
Us to have those numbers?
Well, I'm showing like the solution sheet. For you to get started, I'll show you 1 second. I posted Skeleton. Yeah, you see I posted this skeleton right here. Okay. Now this skeleton has errors here. I don't know why. I just realized last night. The daily cargo shipments numbers are wrong. Okay. So make sure you use those numbers. Otherwise, it may look different. To me. I may interpret it as you making a mistake somewhere. Okay. So it makes sense, right? So look, you have distance here from Philadelphia to each of those cities. Here you have demand for tickets for the day, and here you have demand for cargo. Okay, and here, look, let me zoom in a little bit. And here it's just like totals or averages. So here we have total, by summing all those values, we have total demand, the number of passengers that we'll carry for that day or hoping to carry. Here we have sum of all those cargo contracts, meaning this is how much cargo we'll carry for this specific day. Okay. And here, look, in this section that is highlighted in yellow, we have bus allocations. Now remember the setup. We have different buses here, right? And we have different quantities of those buses, different models with different quantities. So this particular model, D4500, for this model we have 12 buses available for us. We have 12 buses in our fleet, okay? So what you're trying to do here, you're trying to allocate buses, giving this demand for passengers, for tickets and cargo. How many buses do you assign to each route, and of which type? So this is the problem, right? You want to assign, you want to dispatch buses to the route, okay? And here we have, again, we have sums. Now look guys, remember this, I'll bring your attention to this once again a couple of times. This number, the total number of D4500 buses allocated, cannot be greater than this, right? Because you only have 12 buses of that type. So whatever you change here, those are your constraints. You cannot have more than, let's say for D4000, you cannot have more than 8, okay? For all routes. Now let me ask you, like, just based on your intuitive understanding of this problem, when we're trying to assign buses to each of those routes, what kind of goal are we trying to achieve overall? I mean, we're assigning those buses with what in mind? Or let me ask you in a more specific way, when we're assigning those buses to those routes, which variable are we trying to minimize or maximize?
Extra seats. Extra seats.
Well, I don't know. I mean, can you expand on that, please?
Like you don't want a bus carrying, like you don't fill all the seats on. So you don't
okay.
A bus
So first of all, capacity, right? Capacity. Now, we don't want to run empty buses, okay? But again, I would argue with you by saying that capacity is not an end on its own, right? Capacity is a means to what? I mean, what are you trying to do as a manager of a company? I mean, overall. Yeah, maximize profit, right? And profit is calculated by subtracting costs from revenue. So you either try to maximize, increase revenues or minimize cost, and that's how you increase your profit, right? So that's what you have in mind. Now, for now, we'll just do those things with the following goal in mind. We're trying to minimize total cost for the day, and also we're trying to meet the entire demand at the least cost possible. Okay, this is our total cost, and we'll go to this number in a second. Okay. Okay, so let me show you something here. Here we have total passenger capacity for each route. Okay. Now this is how you calculate it. Look, you multiply the number of buses allocated of each type. Let's say here we're talking about D4500, but it's passenger capacity from this table. Okay. And then we add all those numbers. So each bus number is multiplied by its passenger capacity, and then we sum it all up, right? Friends, I forget it. Even in the tutorial, I forgot to do it. Make sure those constants are marked as constant by putting dollar signs, right? Otherwise, you know, the cell will slide. Okay. So make sure you put dollar signs in front of these cells, because total passenger capacity does not change per bus. It's the same for all buses. Okay. Now this thing, which is number of buses allocated, it's not a constant, so that you can copy this formula by dragging it down. Okay. So once you specify this formula, you just drag it down like this, right, to copy it for all cells. Okay. But again, these has to be constants, while these are not constants, so that the formula is automatically sliding down. Okay. So try it out. Like, do it like this, and then drag it down, and then don't put those dollar signs and drag it down, and you'll see that this cells is also coming down with every row that you're copying it down. So it creates like this error immediately. Okay. So basically we're saying, look, for this route we allocated the following passenger capacity, 506. Is it enough, by the way? So far, like, based on those numbers, we allocated 506. Is it enough? Seems to be enough, because total demand is what? 500, right? So in fact, we're having a very good capacity utilization, almost 200%, close to 100%. Okay, but again, I think in real life managers would disagree with that. I mean, I think empirically managers determine that it's not a good idea to run your machinery at 100% capacity, right? Because you have like a lot of mistakes. You have, I mean, if you're talking about buses specifically, maybe there's like too much hassle for people to board because the buses are full. You know what I'm talking about, right? I mean, it makes a big difference when you're flying an airplane that is fully booked versus the one that is half empty, right? Have you experienced both? I mean, it's really annoying when when an airline books airplane at 100%. Because there's no place to move, everybody's screaming, everybody is basically occupying space and making things less comfortable for you, right? So, but again, for simplification, we're saying, yes, we are thriving to have 100% capacity utilization in this particular case. Now, how do you calculate passenger capacity utilized? Well, you divide this number, daily passenger booking, by total passenger capacity allocated based on those buses, something that we just calculated, okay? And make sure you format those cells as percentages. So you go to format cells and specify that you want percentage. I mean, it's up to you if you want to use decimal points or not. I'm not using here decimal points, okay? And make sure in your skeleton dollar values are also formatted as currency. So again, go to format cells and specify that it's a currency, okay? Here it's a custom format. I'm not sure why. Okay. Total cargo capacity. In other words, this is the total cargo capacity that we have based on these allocations. Okay? How is it calculated? Well, again, each bus number, so like this cell, so we have 2 buses of this particular type allocated, is multiplied by this bus cargo capacity, which is a constant once again. So it comes from this cell. Okay? Does it make sense? So similar to this formula, but instead of passenger capacity, you're calculating cargo capacity. So we have 2 buses of D4500 type. This is reflected by the cell F21 right here. Okay, and we multiply it by D6, which is a constant, by this cell. Okay, so this gives us total cargo capacity. And then the same thing, you calculate, and then once you specify formula like that, you drag it down. Okay, and it's calculating total capacity for all routes. Okay. Now here we have a percentage of cargo capacity utilized, and you calculate it by dividing demand for cargo in this cell by the total capacity. So in this case, capacity is very low, right? It's only 29%. But again, somebody may argue we don't want to have a bus loaded with people and loaded with cargo because it will be difficult for a bus driver to drive. It will consume a lot of gas, right? I've just read like recently something that airlines don't like to talk about. Like when they're flying somewhere, they don't put like a full tank of gas basically, right? Because carrying that extra gas will cost them a lot of money. Okay, so they put just enough to land on their route. So and you know what kind of safety problem it creates, right? Like for example, if there is a weather problem, they may not be rerouted easily. I mean, they can be rerouted to a nearby airport, but not an airport that is far away.
To exceed 5 hours a certain amount.
Oh yeah, so there is a law that says, well, you cannot have less than that gas. Otherwise, they will be like running like empty tanks, right?
They have to have like an extra 100 miles within the plane.
Extra 100 miles? Well, that doesn't sound soothing to me. 100 miles, right?
I don't know the exact figure, but they have to have a.
Yeah.
There's a minimum capacity per
Yeah.
a destination.
Yeah, but one thing that you need to know, it's not a full tank, because I always assume it's a full tank and they cannot go anywhere they want.
If they landed with a full tank, they would just dump the gas into the atmosphere if they landed with a full tank.
Yeah. No, I'm saying like initially, like when the flight starts,
No,
they don't. Yeah.
They cannot land with the excess gas. It would destroy the aircraft.
Well,
So they have to dump the gas.
Well, from what I know, it's like it will not destroy, but it will be like dangerous because if fire, they don't like in case of fire, the whole tank will explode. Well, anyways, I don't know the details, but what I'm talking about is that it may not be a good idea to have your bus loaded at 100% capacity with passengers and cargo, right? Based on practical experience.
Also, the bottom 3 or a few of the daily passenger bookings is different from the skeleton in the book.
Bottom 3 where daily passenger here.
Yeah, it was like 250 and.
Okay.
And just.
Okay, thanks.
I'm trying to follow along with you.
Yeah, thanks for noticing. So make sure the numbers are the same. So it's like a trick for you. Okay. I had a conversation with a colleague of mine. I said I've noticed like some students in my class they just browse Facebook. All class. They don't listen to anything, and in a way it doesn't bother me because they're not like disturbing me. Like if they want to browse Facebook instead. And one faculty told me, you know what I do? Like I make a mistake intentionally, like in my number. So if they don't pay attention, they get like wrong result and they get like bad grade for the for the assignment. Now I didn't do it intentionally, but we have. So if you haven't been listening to what Robert just said, then you're lost already, right?
It's actually part of my job to just notice mistakes.
Okay. All right. So here we have capacity for cargo. Here we have operating cost. Now this formula is easy, but it just has like a lot of cells. Look. Okay, C21 is the distance, right, from Philadelphia to Baltimore. Okay, so you multiply this number. So this is like the mileage, right? Now you need to multiply this mileage for all bus allocations along that route. Okay, so in this specific case, we have F21. This number of D 4,500 buses allocated, right, times E6, which is operating cost per mile for this bus. Okay, I think it makes it a bit harder to understand. Think about it this way: you're multiplying mileage by the number of buses by the cost per mile for each model bus allocated, right? So here we're just putting it outside of the parentheses to make it a bit shorter, right? But basically, it's like 3 terms multiplied for each bus model, right? Does it make sense? So it's basically mileage, number of miles buses have to travel, by the number of buses allocated this cell, by the cost per mile, which is this cell for each model, and then you add it all up, so you get this total cost for operating this particular route. Okay, and here we just have sum. Okay. Now for now, let's ignore this additional cargo. We'll go back to that. So basically. I'll just mention that additional cargo means this: if you have more cargo capacity, and in this case we do, then you have orders, right? Then you can resell that cargo capacity to somebody else. So basically, it means like from your clients, there's not enough capacity, so perhaps you can ask a competing bus company whether they have a shortage of capacity, and they will sell it to you. And by the way, if that happens, the ongoing price is $1 per pound. So in other words, bus companies, including Saint Bernard, they sell extra capacity to their competitors at $1 per pound. Okay, so basically it means like, look, if you have 18,500 pounds extra capacity, you can sell it to a competitor in theory for $1 per pound. That's what it is. But for now, let's ignore it. We're not taking into account this. What we are worrying about costs. Okay, so this is our total cost, and we're summing up all those costs for operating all those routes. Okay, now what I will do, what I suggest, although it's not required, you can try to allocate those buses manually, and just keep in mind the constraints. This cannot exceed the total number of buses available, and also you need to keep everything under 100%, all capacity utilizations. Okay, so you can manually try to enter numbers and see what you can come up with, whether you'll be able to minimize that cost. Okay, but what I will do, I'll just put one, and one is my initial guess. I'm just saying initially I'm guessing that I'll put one bus, one model for each route. So in total, 4 buses for each route. Okay. Now the cost went down, right? But we know that capacity. We also see that capacity utilization here is not meeting constraints. It's all 100%. Okay. So in other words, we don't have enough capacity, passenger capacity, to meet the demand. So this is not a good guess. Okay. So I'm just saying. Well, I started by saying 1. So maybe I can put, I don't know, 2 buses of this type. So it improves a little bit. It goes down to 185%. So if I put twos, okay, let's say 3, 4 here, or 3. So it's over 100% still. So let's put 3 here. Okay, so this seems to be a bit better, right? $93. So I can manually figure out that 93% capacity is based on this combination.
Real quick, back to operating costs. What else was involved besides C21?
That's it. Basically, you multiply mileage for this particular route, right? Per cost per mile per bus type, which is right here, and then you also multiply by the number of buses that you allocated. Okay, and then you sum up all 4 terms. Now here, it's basically C21 mileage is taken out of the equation, right? But in reality, it's like 4 terms that involve 3 multiples, like this, right? Because this one is outside of the equation. Now, so you can do it like manually using your own human intelligence. And I the funny thing is that a lot of people do that. It's a lot of practicing managers. They do things like that manually. That reminds me about my boss. He had a PhD degree in operations management, right? So operations management is a subfield of management that deals exactly with those kind of problems, scheduling, capacity allocation, right? And the funny thing that I've noticed about him is that whenever he schedules, and he was associate dean in my college of business, he was responsible for scheduling classes. He never uses any software. He always does it manually, like this, in an Excel sheet, okay? So I asked him, like, well, but like all those theories about optimization, why don't you create like some kind of software model, like in an Excel? And by the way, you can also buy it. Like there are a lot of vendors out there that are selling those scheduling applications. And you know what he said? Well, this software just doesn't work in real life because there are so many human factors that needs to be taken into account. Somebody just had a newborn and doesn't want to teach classes at night because they need to take care of baby. Somebody is pursuing certification, so they want to teach all of their classes on Mondays and Wednesdays. So he said all those intangible human factors cannot be entered into software piece. That's what he told me, right? But Excel does have functionality to do these things on your behalf, to find like an optimal combination. And that is called solver, right? So you'll be using solver for find an optimal combination of those buses for the ultimate purpose of minimizing total cost, which is this cell. And by the way, we're color coding. I'm not sure whether it's a good color combination, probably bad, because it's not that different. But for yellow cells, yellow sense means those are the factors that will vary. Those are our variables. So in our case, we'll try different combinations, and they're highlighted of buses, and they're highlighted in yellow. Now, golden color means this is our target variable, optimization variable. Okay? So remember, like in the very beginning of this class, we talked about optimization approach to decision making. Optimization means you're trying to minimize or maximize a certain variable. Okay? Okay, so solver found in this data tab right here. If you don't see it in your Excel version, it means you need to go to File Options and you need to enable it. Okay? If you cannot find that option of enabling Solver, it means that you need to download it from Microsoft website. But usually Microsoft Excel comes with Solver pre-installed. You just need to enable it in Options if you don't see it in the Data tab. Okay? So look, when you press Solver, you see the following window. The first thing that you need to do, you need to set objective, and using dollar signs to say it's a constant. So in our case, objective cell is N27, this one, total cost. Okay? So we are trying to optimize this particular cell, total cost. Now, more specifically, we are trying to what? Minimize or maximize it? Minimize it, right? I mean, you don't maximize your total cost. Okay? Now, the next thing that it asks you, by changing variables, so you're trying to minimize this cell by changing what cells? And you're specifying this range from F21 to I26. From F21, this cell, to I26, meaning this entire range. Okay? So you're trying to changing this range. Now here we have a number of constraints entered. I already mentioned those constraints. Okay, I'll go over them once again. So basically what you can do, you can add those constraints one by one by pressing Add, and then you specify which cell, what kind of operator, and what kind of constraint. Let me go through those constraints one by one. First of all, you're saying the entire range of F1 I26 equals an integer. Okay? That's how you do it. You just say add, and here you specify this range, and then here say equals, and here you just put integer with words. Okay? It makes sense, right? Buses cannot be decimal. It cannot have. Bus allocations cannot have decimal points. You cannot allocate 1.3 buses to a particular route, right? Doesn't make sense. Okay? Here, same range is greater than 0. Again, makes sense. You cannot allocate a negative number of buses to a particular route. I mean, you as a human, you understand those things. It seems obvious, but computers are not as smart, right? I mean, if you're asking computer to minimize cost, it may put negative numbers here. Okay? So it's saying, no, those numbers cannot be negative. Now here, those three cells, we're saying F27 has to be less than G56. What we are doing, we are making sure that the computer is not allocating more buses than we have. So we're saying S27, which is this, one second. Yeah, F27, this cell, 7, has to be less than G6. And G6 comes from here. So we're saying don't allocate more than 12 buses. Right? Because we only have 12 buses. Okay? So this number 7 needs to be less than this, which is total allocation for this specific model. And we do it for all 4 models, right? We do it for all 4 models, okay? And the remaining cells, it's capacity utilization. So we have like 5 routes, so we have 5 expressions saying this capacity, J21, has to be greater or equal than D21. So J21, this cell, has to be greater or equal than D21, meaning we need to allocate at least the same amount of passenger capacity for each route, okay? And we do it for all 5 routes. So we have 1, 2, 3, 4, 5, yeah. And then we have, it's 6 routes, so it's 6, yeah. And then we have the same thing, the same constraints for for cargo capacity. We're saying S21, so it's L21, yeah, has to be greater than E21. So L21 is here, right? Total cargo capacity. It has to be greater or equal than E21, than this cell. So we're doing it for all routes. So in our case, it is, right? So we have more cargo capacity than the demand. So that's another set of constraints. You have 6 constraints related to cargo. Does it make sense? So they're just saying we cannot have less cargo capacity than the demand. We need to meet all the demand. Okay? So those are our constraints. Now, make sure you check this button, make unconstrained variables non-negative. I mean, if you look at all of our variables, we didn't constrain all of them, right? But it's clear that we don't have any negative numbers here, right? So just to be safe, we're saying they have to be positive. All of those numbers have to be positive, okay? So we put check mark here. Now, the other thing that you're doing, you're specifying you're going to use simplex LP algorithm. LP basically means linear programming. I think you're not required. Are you required to take supply chain management, operations management? Well, if you take a supply chain operations management course, you will study those linear programming algorithm. They are exactly this. Those algorithms, they tell you how to optimize certain things in a linear fashion using linear equations. Okay. Now, look, guys. In our case, we're trying to minimize this value, right? Now, this value is a linear combination of these values, which makes sense. I mean, look, we calculated this value by adding or subtracting or multiplying these values, right? I mean, I'm just giving like the overall approach. So in other words, there's a formula that brings us from here to here, right? By definition, we just entered those formulas, right? So there's a formula, right? And this formula is linear. It doesn't have like some kind of sudden moves or sudden shifts. It's based on addition, subtraction, and multiplication. That's it, right? So that's why we're going to be using linear, a simplex LP linear programming algorithm. Yeah, I was just going to put it back. I was showing those cells. So that's why we're using simplex LP algorithm. Okay. Now there are some other options. By the way, I posted the link to this section on Canvas, like it's from this book, Microsoft Excel for Dummies, that explains like all those parameters in detail, what those parameters are. I'm just going to mention some of them. If you click on options, right, here we have constraint precision. So now it's like, what kind of number precision do you want to use? So here it has like high precision, basically, right, like this decimal point. Use automatic scaling. Make sure it's checked. You know what happens? Sometimes you have different numbers in your model that have different magnitude. Let's say billions of dollars versus number of employees. Now, number of employees will be measured in thousands, and billions of dollars measured in billions. When you have this kind of scale differences, it may make things a bit complicated for the solver to optimize your model. So you're saying automatic scaling, and now bring everything to common denominator. That's what it means. Okay. Show iterations results. Again, if you have too many iterations, it will have too many results. So I'm not checking that. Integer optimality. I'm putting 1%. You know what you're trying to say here is saying, I understand that finding an optimal solution may take a lot of time. I'm okay with being within 1% of the optimal solution. Now, what you're saying, you don't need 100% precision. Okay. So in our case, let's put 5. We're saying we're okay with 5 precision. 5% with being like 5% around the optimal value. Why do you think I'm doing this? Why do you think instead of saying I want to be 100% precise, I'm saying I want to be within 5% of the actual optimal value? What do you think it will help me to do if I'm not seeking a very precise solution? And also, I'm saying I want an approximate solution. I want to have a precise solution. It will save computing power. In other words, computer will not be running all day, because sometimes to solve those complicated models, if you don't have a supercomputer, your desktop computer will have to be running all day to find a solution, right? So I'm saying I don't want it to be running all day, so that's why I'm okay with approximate solution. Okay. Maximum time. So here we have 60 seconds, which is 10 minutes. That's too much. I'm just gonna set it to 150 seconds. Okay. Instead of iterations, I'll just put time. Okay. And then you can read about other parameters, that you may experiment. What I'm trying to tell you, look, guys, make sure you allocate plenty of time for this specific scenario. I think it should be enough to have like 2.5 minutes. For the next scenario that I showed you, sometimes you need to run it for 5 minutes to get a good solution. Okay. Otherwise, the computer may not have enough time to find a solution. And then experiment with this. If you're not finding any optimal solution, then decrease your precision. Try with 1%. If computer keeps running and you don't have any solution, then decrease precision to 5%. Okay. Now, when you press OK, computer. Okay, so you enter those options and then you press solve. So your computer starts finding combinations. The exact time will depend on the complexity of your model and the power of your computer, right? So I'm just gonna let it run, I set 150 seconds, which is 2.5 minutes. So I'm hoping that within those 2.5 minutes, it'll find a solution.
How did you say you got solver?
I'm sorry?
How do you get solver?
You go to data, and then there's a sub-tab that's called solver. If it's not there, you need to go to options.
It's not.
Well, that's why you need to watch tutorial D, like where I show you how to enable it. So go to the first part of tutorial D at home, and it shows you how to enable that option. Okay, still running. By the way, I don't know what will be. You see, what happens is that if you don't find a solution and you select to continue, you need to basically you need to do Control Alt Delete and then end task, because I don't know what is a good way to stop it. Maybe control break will help it. So it's still running. It still hasn't found a solution. I mean, you understand it's kind of brute force approach, just trying different combinations to see whether it can find a good solution, optimal solution. And by the way, because there is a degree of randomness involved, each time you run, like sometimes I find like a good solution within 10 seconds. Sometimes I run it for 3 minutes and I cannot find a good solution, right? And every time the solution may be different. Of course, if you allocate more time, you should get a better solution. Maybe I'll pause our recording. Yeah, basically, what I'm saying is that we found after running it for 2.5 minutes, we found like a suboptimal solution, meaning an okay solution, not a globally optimal solution. The solution is reflected here, and we pressed, we saved the answer in this particular tab, answer report. When it gives you this output, there's an option. You just need to click on this answer. Again, it's shown in your tutorial D. You click on this answer, and it saves like the details of this optimization cycle in this separate tab. Okay. So what do you think? It's not too bad, right? So look, our passenger capacity is kind of close to in the 90s on average, right? High 90s, which is good. Our cargo utilization is kind of low, but still we're meeting all the cargo demand, right? We are underutilizing cargo capacity. Okay. Which brings us to the next optimization problem. And by the way, you don't need to do this because if you do like the second optimization problem, it kind of assumes that you did this part correctly, that you entered everything correctly. Okay. Now this brings us to the cell about additional cargo capacity. Now here, look, it's actually like a simple formula. However, it's a nonlinear formula. It requires like a logical operator being applied. So look, this is how this formula works. You're saying if L21 is greater than E21, L21 is this, your total capacity, is greater than the demand, right? Then you can sell the difference. In other words, you can sell the difference between this value and this value. So in other words, you can sell all the extra capacity, okay? So that's how you calculate it. Extra capacity means the difference between total capacity and the demand for capacity. Otherwise, zero. In other words, if zero means false, this number is not greater than the number, meaning you are already at 100% capacity, you have nothing to sell. In that case, it will be zero. Okay? And you do it, if you drag this formula down, you'll drag it down and you'll calculate this extra capacity sold for all routes. Okay? Now here, you need to go to your income statement. First of all, you have overall passenger revenues. Okay? You calculate those revenues by multiplying tickets that were in demand for this particular day by their price, because your decision model is built to meet all the demand from customers. So you multiply each cell like 500 times 90, 250 times 179, and so forth, and you add all those numbers. So here you get passenger revenues. Here you have cargo revenues. Again, the same idea. You multiply pounds per route by the price, cargo price per pound. Okay, so you add all those items and you get total cargo revenue. Additional cargo revenue comes from this cell. By the way, we're not multiplying it by dollars because it's like $1 per pound. So we're just saying this cell equals to 0.27, and then you just format it as dollars, right? So you don't have to multiply it by $1 basically, because it's $1 per pound. So this is total revenues. You add all those numbers together. And here, operating cost. Operating cost comes from this cell. We already tried to minimize that cell, right? So total revenues minus operating costs, you get daily gross profit. So that's your income statement section. Okay. Now what you will do next, you will try to run solver for this specific cell. So let's format it just like this one, because this is the color coding that we're using. So this becomes our optimization cell. So we'll just copy format. Okay. So we'll try to optimize this number. And by the way, save it in a different tab. When you try to run a different problem, like copy it in a different tab. So I already have it saved, have a copy. It's like the same values basically, but different tab. So for second optimization problem. And by the way, you only need to submit this tab. This tab together with the answer report. Okay. So now I'm recording it. I'll show you exactly how to generate that answer report. Again, you need to go to data solver. Okay. Now, set objective. Now it's not N27, it's not that cell anymore. You're setting it to C35, which is this cell. Okay. Now, if it's a daily gross profit, we're not trying to minimize it, we're trying to maximize it, right? Changing cells, the same thing. We're changing those bus combinations. So those cells highlighted in yellow will be changed to optimize, to maximize this value. By the way, constraints are the same that I showed you in the previous problem. In the previous optimization problem. The same kind of constraints. And again, make unconstrained variables non-negative. Okay? Now, what's going to happen, look, if you're trying to run simplex algorithm, just in case I'll put options 10 seconds, because you never know, maybe it will run. If you try to press solve, it gives you an error. Okay? Why do you think it gives you this error? It says you cannot use linear algorithms for this problem. What's non-linear about our model here? Which column is nonlinear? Which one, Ashley? Yeah, extra cargo capacity is not, because you see it has this if statement. It's not. I mean, it's not an algebraic operator. It's a logical operator. So that's why it's nonlinear. Okay, because we have if then. So it's like some kind of judgment, some kind of leap, non-arithmetic leap in decision making, right? So that's why we cannot use that simplex algorithm. Instead, going back to the solve, we'll use nonlinear. Okay, it's called GRG nonlinear. I forgot what GRG stands for, to be honest. Then again, you go to options, and here I'm telling you, it's a more time-consuming algorithm because nonlinear involves like a lot of guessing, a lot of randomness. Okay, use automatic scaling, integer optimality. I'll set it to 5%. Okay. Because otherwise it may take us like with this particular computer, it may take us like 15 or 20 minutes to find a solution. Okay, and also I'm gonna set max time. I don't know, 200 seconds, which is 3.33 minutes. Okay, so I'll put it like for 200. So I don't know whether it's gonna find an optimal solution or not. Okay, so let's try. So right now we have 341. So let's do this, just like we did with the previous problem. We'll put like initial, so we see like whether there's any improvement or not. Because I already ran optimization here, so I already have like an optimized value here. So let's set everything to 1. So we're starting with our initial manual guess again. So I'm putting everything equal to 1. So you see our gross profit went from 300,041 down to this number. So again, we go back to solver. So yeah, make sure it's nonlinear. In options, I'm putting 200 seconds, and I'm putting 5% optimality, meaning we don't need to have precise solution, within 5% of the optimal solution. So we press OK, solve, and we let it run. So now we'll wait to see whether it will find an optimal solution. I'll put it on pause for now. Okay, so you see, after like 1 minute or less than a minute, you get a message from Excel. Solver found an integer solution within tolerance. All constraints are satisfied. Okay? So if we press OK, so you see the gross profit improved from 200,000 to 300,039. Okay? By the way, I was able to get like, by running it long, I was able, and setting precision to 1%, I was able to get it like in the 40s. Okay? But since like we're just doing for demo purposes, let's do it like, I forgot to show you how to save the answer again. So let's run the solver again. The same parameters. Okay, let's put it back to 1. So we'll run it again so that I show you how to sell. And basically what you need for your homework, you need to have this kind of output that I just generated by maximizing gross profit. And also, don't forget, I'm asking you to interpret. Maybe you can put like some kind of memo next to this. You can say, well, it looks like optimal combination involves overutilizing cheap buses and underutilizing expensive buses based on the operating cost per mile. Just give me some insight, some kind of interpretation or analysis of your results. So let us run it again, if you don't mind. So again, nonlinear options for 200 seconds. Okay, let's run it. And I'll put it on pause. Okay, so we get this message from Excel saying we found like a solution that seems to be integer, meaning whole number, and seems to satisfy the constraints. So you say, yeah, I want to keep the solver solution, and just click here. You're saying, I want to save answer report. Okay, so when you press OK, you see, I think it's this one. It generated this additional tab with all the details of the algorithm. You're saying we were able to go from 293,000 to 339,000. Okay, so make sure you save that output sheet. Okay, and make sure you have this. The second sheet that you need to have is this, and make sure you add some interpretation. Now look at the solution and give me some analysis. Like, do you see any patterns here? Okay, what did this solver algorithm help you to find out about optimal allocation of buses? Okay, so that's what you need to do. By the way, I re-uploaded the assignment because I found an error. It was like a kind of ironic error. The old assignment says you need to minimize gross profit, which doesn't make sense, right? You need to maximize gross profit. So I re-uploaded that file, so it needs to be maximize gross profit, not minimize. Okay. If you open assignment 7, it crashed. Well, anyways, if you open assignment 7, it will give you exactly the same thing. You just need to submit 2 Excel sheets. This sheet, where you worked on your maximization problem, this sheet that is automatically generated, that gives detail of your solution, and also make sure in this sheet you write some kind of interpretation near this table so I can easily see it, right? Just write like a few sentences here with your analysis.
It can be the same file with different sheets.
Yeah, same file, 2 different sheets, yeah. Okay, so any other questions about this model?
So 2 sheets and 2 answer sheets.
Well, it's basically one Excel file, and they call them sheets, right?
Yeah.
Worksheet.
Yeah, workbook is the entire file, right? And sheet or worksheet is like with this tab. So basically, you have one file, meaning one workbook with 2 sheets. Answer report and this decision model with the optimized or maximized daily gross profit. It's written in that Word document as well, so you don't have to write it down. Okay?